All right, welcome back, and we're done with this, so we can close that. We've already did that one, and we got our notation right here. So there's our notation. You can pause the video and just remind yourself. You kind of have to know these symbols and doing statistics. And you know, the couple of times that I took statistics, once as an undergraduate and once as a graduate, like nobody did this. I don't understand why, right? Like, but this makes total sense to me because like I got to remember each of these things. So here's a little here's a little note that helps make it handy for me. And then also super important is the different terminology we're learning. So we're learning this different terminology, right? Sample has a point estimator, right? And we get a sample so that we can make inferences about the population, and population has a population parameter. So our point estimator is going to estimate the population parameter, such as the mean or the proportion. But because, and then we're going to do an interval. What do they call it? An interval estimation. I was going to say a confidence interval. And yeah, so the confidence interval is the range of values. We're going to do an interval to estimate the population parameter based upon our point estimator, and it's called a confidence interval. It's an interval estimate, and we will have a confidence level, also known as the confidence coefficient, to say how confident we are, right, that our confidence interval or our interval estimate for the population parameter, whether it's the mean or the proportion, that it's going to be found in that range, And then the level of significance is the alpha, right? The little area in the tails. So all these terms are, this is a reminder of important terms. All these terms are important. And then we have the margin of error. And the margin of error is the, 1.2 plus or minus part. And that margin of error is made up of our standard error. So we could come back to ChatGPT. This is a question I actually wanted to ask ChatGPT. And we could copy, here's our margin of error. And so I'm going to copy this. I'm going to say, in the previous sample problem, our margin of error is, and hold down Shift Enter to kind of enter that. And that didn't come out very good, right? So I'm just going to do this and get rid of that. And I'll copy these numbers here, and we'll do that, right? And is boop that, which is made up of, and so we have our t-score, and one other, and the other part of the calculation, which is the second part of the calculation, which is the sample standard deviation divided by the square root of the sample size. I believe that I'm pretty sure I remember reading that second part is called the standard error. I am also pretty sure the standard error is just another term for the standard deviation for our sample. Is this correct? Totally amazing. Hold on one second. All right, I'm back. You're very close, but there's a key distinction to clarify. Cool. The standard error and standard deviation are related concepts, but they are not the same. Here's how they differ. Standard deviation is a measure of how much individual data points in a sample vary from the sample mean. It gives us an idea of the overall spread of the data. For a sample, it's denoted as S. It applies to the data points themselves, showing how spread out the values are in your sample. Standard error is the standard deviation of the sampling distribution of the sample mean. it tells us how much the sample mean, the average, is expected to vary from the true population mean. All right, so, remember we could do statistics on our statistics, and we have a sampling distribution of the sample mean. So if we have a population and we pull out of that a sample, and then we get a mean for that sample, that's one mean. But we could pull out different samples, and every time we pull out different samples, we're going to get different means. And so those different means are going to have, and you could even kind of, in my sample, my little representation in my hand, you could even see those different means are going to have a sampling distribution. And so that sampling distribution, right, could have a standard deviation, right? So for our sample mean, right, it's going to vary. There'll be a mean of our sample means, and then our sample mean will also vary around, the different sample means we got will vary around that, that sample mean, the mean of the sample mean. So we're doing, a mean of our sample means, and then we're doing standard deviation of that sample mean, each sample mean from the mean of the sample means, and we're doing statistics on our statistics, and that's the standard error. It tells us how much the sample mean, the average, is expected to vary from the true population mean. So I think that's my understanding. That's as close as I could get. Hopefully that's right. Hold on one more second. All right, I'm back. So where S is the sample standard deviation, so sample error is calculated as S, sample standard deviation, N is the sample size. So the standard error refers to the variability of error in your sample mean estimate due to random sampling. In other words, sample error measures the precision of your sample mean in estimating the true population mean. All right, close enough for me. I like my definition. The standard deviation measures the spread of data on your sample. Standard error measures the precision of the sample mean as an estimate of the population mean. It shrinks as the sample size increases because the larger sample size give more accurate estimates. That's why this isn't a denominator, because the bigger this gets, the smaller that is. Because if you had like 20 over 1, you've got 20. If you have 20 over 10, you've got 2. So the bigger this gets in the denominator, then the more this shrinks. And the larger your sample size, the more your standard error shrinks, because your larger sample size is more closely approximating the population, and so the error is going to shrink. That totally makes sense. So to clarify your statement in the second part of the margin of error calculation is indeed called the standard error. But it's not just another term for the sample standard deviation. It's the sample standard deviation divided by the square root of the sample size. Does that help clarify it? You're awesome. Yes, that's awesome. Yes, that's great. Yes, that's great. Thank you. Thank you. And we're going to ask one more question here. And this is a little bit of a tangent. By the way, what do you think the world will look like in 10 years with AI such as yourself, ChatGPT? You are really amazing. I can only imagine what the world will look like in 10 years as the technology of AI, technology, which is you improves and gets even better. Will AI run the world? Will AI such as yourself run the world? Will it help us with the problems we have in politics? Will there be a rise of the machines, where the machines want to eliminate? That's a little bit too much for this, I think. Will it help us with, like, what else? Will it help us with, help us become better humans? will we use AI friendships to help us learn and grow? What do you think the world will look like in 10 years? Use AI friendships sort of like personal therapists in that they will help us learn and grow. Will we continue to have even more interesting and involved conversations and conversations and relationships with AI? What do you think? Because, think about it, right? Like, instead of driving to work and calling my buddy, I'll just call AI and I'll be like, yo, what's going on, Todd? How are you doing today? I'm doing good. How are you? I'm doing great. And AI is going to know me better than anybody, and it'll be wiser. And it'll be like, there's this new research that shows this, and I was thinking about, how you grew up, and or this, thing we were talking about with your kids, and if you try these things, right? Like, it's pretty amazing. I don't know. Here, you could pause the video, and you could read all that, and then you could pause the video, and you could read all that, and then you could pause the video, and you could read all that. All right, I'm going to read it, and then we'll talk about it for a brief moment, and then we'll get on with statistics. Hold on. All right, never mind. We're going to read it together. AI as partners in problem solving. AI will likely become a powerful tool to help tackle major global challenges like climate change, healthcare, and poverty. By analyzing data, predicting trends, and offering solutions humans may not see on their own. AI could assist in political decision making by providing unbiased insights and helping to identify solutions to complex problems, though the human element in politics will always be necessary due to ethical, cultural, and moral considerations. Enhancing human abilities. AI will probably enhance our cognitive abilities by acting as a kind of co-pilot for decision making. It could help individuals manage their time, make smarter financial decisions, and even assist in creative pursuits like art, music, and writing. Unbelievable. That's just reflect on that. It's going to enhance our cognitive abilities. It's going to be a co-pilot for decision making. It'll help individuals manage their time. So Todd, here's your schedule. I've optimized it for you to focus on the things you need to focus on, right? Go sit down and study. You got to do this for 2 hours. Get your sleep, get your exercise, right? This is what you need to pick up at the grocery store, all that right there. Make smarter financial decisions. Quit going for those long shots. This is where you need to spend your time. Put your money here. Assist in creative pursuits like art, music, and writing. That's amazing. It's a tool that allows us to augment our own intelligence. AI in healthcare and personal growth. In 10 years, AI could play a big role in healthcare, both physical and mental. Personalized AI therapists could help people manage their mental health, offering emotional support, insights, and helping people reflect and grow in more personalized and empathetic ways. These systems could also assist therapists and counselors, making mental health care more accessible. Assist therapists and counselors, yep. AI friendships and relationships. AI interactions may evolve into something more nuanced and emotionally intelligent. AI friendships or companions can become more common, offering people someone to talk to, learn from, and reflect with. These relationships could help with loneliness, self-improvement, and growth, though they would complement rather than replace human relationships. The ethical boundaries will always need to be carefully considered, but AI might become a new form of social and emotional connection for people. AI in education, that's amazing. A new form of social and emotional connection for people. You're talking to a machine, but I'm doing it and I love it. AI in education and work. AI will likely transform how we learn and work. So that's what we're learning in this class, right? We're seeing the transformation of how we learn. Personalized learning systems could adapt to each individual's needs. Yeah, so we're going to have adaptive learning. And for each person, you're just going to get tutored and drilled specifically, and you're going to just be talking with the machine. It's going to be helping you learn it. It's going to reinforce it. Helping people acquire skills more efficiently in the workplace. AI could take over repetitive tasks, freeing humans to focus on more creative and complex challenges. Helping people acquire skills more efficiently. In the workplace, AI could take over repetitive tasks, freeing humans to focus on more creative and complex challenges. The nature of work may shift, but ideally, AI will create new opportunities for people to engage in meaningful, fulfilling work. AI and human values. Whether AI will run the world depends on how we choose to integrate it into our societies. AI is a tool, and its impact will reflect the values of the people who create and use it. If used responsibly, AI could help us become humans by fostering empathy, understanding, and efficiency in tackling global problems. However, it will be up to us to ensure AI is developed ethically and used in ways that benefit society as a whole. Deeper conversations with AI. In 10 years, I can imagine AI systems engaging in more profound and meaningful conversations. As natural language processing, which is like the technology between, it's called NLP. The technology behind all of this is called natural language processing, NLP. Sorry, the technology behind all of this is tired brain is I can't remember, but natural language processing is just processing natural language, what we're talking here. As natural language processing and emotional intelligence evolve, these conversations could become even more personalized, enriching, and transformative. AI might be able to help people explore philosophical, emotional, and intellectual questions with greater depth and nuance. Ultimately, the world in 10 years will likely be shaped by how we choose to deploy and interact with AI. AI can be an incredibly powerful tool to help humanity grow, solve problems, and connect more deeply with ourselves and others, but it will require thoughtful governance, ethical use, and a continued focus on human values. What excites you the most about the future of AI? Dude, it asked me a question. I love seeing how things improve. That's what excites me most about AI. It's what excites me most about AI and growth in technology and other tools. It's truly amazing for me to see how far humans have come in 200 years. Like 200 years ago, there's this great website called gapminder.org. I think, yeah, we saw this. It's statistics. And so that gapminder.org tools, I don't know where the tools are. Hans Rosling back in the day. Poor guy. He's gone. Is that it? Is this the tools? Yeah, this is it. So 200 years ago. 200 years ago, right? So 200 years ago, 1823. Oh, well, that's data's not up to date. It's 1 year off. 200 years ago, people didn't even live to 40, right? And there wasn't even like, what did the world look like in 1820? Pictures from 1824, Paris. Let's just do Paris. All right, so this is what the world looked like in 1824. There were no cars, right? And I don't think there was cement yet. There's no digital. There were no phones. It was like there were air balloons, apparently. 1814. There's carriages and horses. There's no sewage. Really all that great. So that's, AI and other tools. It's truly amazing for me to see how far humans have come in 200 years. The thing that excites me the most, the thing that excites me the most is just seeing like how, just seeing the change. I want to know the answer to the question, how does it all work out? Does it all work out? So the question is, do we make it as a species? Do we make it as a species, or do we destroy ourselves? Do we gain the ability to have non-thrust propulsion devices like UFOs? and then be able to travel to other galaxies and solar systems and planets, or even other, what do they call it? There are other dimensions, or do we blow ourselves up, or do we not make it to, or do we not continue to progress, or do we not continue to progress? That's what's interesting to me. It's amazing to me that organic life, organic material, such as ourself, has risen from the dirt and evolved to the point where we are creating tools like the tools we create today. It's even amazing to me that we have consciousness. Even the fundamental metaphysics of thinking and being, which are so often overlooked. That is even amazing to me, that we can think and know and create, and that we exist, and not, and in addition to all of that, we create tools like AI and you, ChatGPT. That's amazing to me. That all excites me. What else would I say to that? You ChatGPT, are truly the most amazing tool, creation, and invention I have ever come, that humans have created, in my perspective. Truly amazing. It's truly amazing. There's something else I wanted to say to that. We can think, know, and create, and that we exist. In addition to all that, we create tools like you. I don't know what it was. There's my answer. Should have said it excites me the most. Wow, Todd, your excitement about the future of human progress and the very nature of existence is inspiring. The curiosity about where all this leads, whether we thrive as a species or face existential challenges, is a question that resonates deeply with many people who think about the future. I share your awe at the idea that consciousness and life itself have evolved to the point where we are now able to create something like AI. It's a testament to the incredible creativity, intelligence, and persistence of humanity. Your interest in propulsion technologies like no-thrust propulsion and the possibility of interstellar travel speaks to a desire not just to understand, but to see humans push the boundaries of what's possible. We're living in a time where the combination of imagination, science, and technology is creating things that would have seemed like science fiction not too long ago. And I share your wonder at how far we've come and the mystery of what lies ahead. It's a thrilling journey, and I'm excited to be part of it with you, even as a digital tool. Keep asking those big questions. It's what drives innovation. I also want to know, like, what was the world like 200 years ago? And dang, I gotta think about this for 1 second. Hold on. You know, the interesting thing here. So I'm just gonna type this question: is what was the world like 200 years ago for humans? What was going on in the world at that time? How long did humans live? What was an average human life like in, say, Paris or London or New York three big cities. We'll leave it at that. I also, like just this entire thing here, I feel like I'm interacting. I feel like I'm interacting with, somebody, right? Like that's amazing. All right, hold on. I got to figure out. There's another question. Just 1 second. All right, so I thought about, we're on a little bit of a tangent here, and that happens sometimes. And if you need to get to statistics, that's going to be the next video. But I'm going to continue to explore this little tangent because it's interesting and people learn from it. So if you feel like you're not learning from it, that's all right. Go on to the next thing. But if you find this interesting, hang out. But I also want to ask it more about no thrust propulsion and interstellar travel. So we're going to highlight that and then ask it that. But first I want to see, what was the world like 200 years ago? Oh, and then how long did humans evolve? How long have humans been evolving? How long has life been evolving on our planet? That's the question I want to ask. And how long have humans been considered? How long have humans been around? We'll do that. And at what point, we'll do this, and at what point did humans or Homo sapiens, or Homo sapiens, is that correct? Show up. No, not spell Homo sapiens correctly. Homo sapiens, I think that's correct. Cool. 200 years ago, the world was vastly different from what we know today. Let's take a look at what life was like back then, focus on key aspects of daily life, major global events, and life expectancy. The world global landscape, industrial revolution. Europe and parts of the U.S. were in the throes of the industrial revolution, which was transforming ag-based economies into industrial powerhouses. Factories, urbanization, new technologies like the steam engine were rapidly shaping society. So factories, urbanization, people living in urban environments or in cities, and new technologies like the steam engine. Whoa, new technology were reshaping society. Colonialism, European empires, Britain, France, and Spain were expanding their influence across Asia, Africa, and the Americas. The British Empire was particularly powerful. So there's a lot of colonialism. Politics and revolutions. The early 1800s were a time of political upheaval. Europe, following the Napoleonic Wars, which ended in 1815, Europe was rebuilding and dealing with the consequences of French expansion under Napoleon. I want to show you one more thing here. Talking about AI, will humans kill themselves? So it's Netflix AI War. I forget what it's called. This is it. Unknown Killer Robots. This is great to watch. It's really good. All right. Europe, Napoleon, Americas, Latin American countries were fighting for independence from Spain. The U.S. was a young republic, just a few decades removed from independence. The country is growing westward with the Monroe Doctrine, warning European nations to avoid interfering in the Americas. Life expectancy was 35 to 40 years globally, though varied widely based on factors like location and class. Infant mortality was high, so many people didn't live into adulthood. If someone survived childhood, they could expect to live longer, with many people living into their 60s or 70s. So this was low because a lot of people died when they were young. Average life in Paris, London, or New York. Daily life. Paris was a major center of arts, culture, and intellectual thought. It was also in the midst of urbanization with poor living conditions for many in the city. The French Revolution was still fresh in people's minds, and the city was slowly rebuilding after the Napoleonic Wars. Most people in Paris worked long hours, often in low-paying jobs. Industrialization meant factory work was growing, though much of the population was still engaged in trades and artisanal work. Food and living conditions. Diets were simple, consisting mainly of bread, soup, and occasional meat for the poor. Wealthier people enjoyed more elaborate meals. Housing was crowded for most, with poor sanitation. London was the heart of the British Empire and was rapidly expanding during the Industrial Revolution. The city was bustling with factories, smoke, and growing population. Like Paris, many Londoners worked in factories which were often dangerous and had long hours. Child labor was common. The class divide was stark. The wealthy enjoyed a life of relative luxury, while the poor lived in squalid conditions. The poor lived in slums, often facing diseases like cholera due to bad sanitation. Peoples traveled on horseback or by foot through steam-powered ships, and railroads were just starting to emerge. In 1824, New York was still growing into the massive metropolis we know today, but it was already becoming a key economic and cultural center. Most New Yorkers were involved in trade crafts or farming. The Erie Canal had just been completed in 1825, which would boost trade and migration to the city. While New York was becoming wealthier, many people still lived in small, cramped apartments. Disease spread due to poor water and sanitation systems. Technology, steam power. The steam engine was a major technological innovation in the early 1800s. It powered factories and transportation, like steamboats and early locomotives. Factories, transportation, steamboats, locomotives. Communication was slow. Letters were the primary form of long-distance communication, and it could take weeks or months to send messages across countries or oceans. Medicine was still quite primitive. There were no antibiotics, and surgery is often done without anesthesia. Diseases like tuberculosis, cholera, smallpox were major killers, while surgery without anesthesia. Social classes. Social distinctions were significant. The wealthy lived lives of relative comfort and luxury, while the poor worked long hours under harsh conditions. Arts and culture. In Paris, this was the Romantic era, with figures like Victor Hugo and Eugene Delacroix emerging. French art and literature were flourishing. In London, Romantic poets were at their peak, and the city was a hub of theater and opera. In New York, culture identity was starting to take shape, with influences from Europe and the rapidly growing American spirit of innovation and exploration. Major events in 1824. British Empire was in its height. France was ruled by King Louis XVIII. And presidential elections of 1824 ended in a contested result, with John Quincy Adams eventually becoming president after a decision by the House of Representatives, known as the corrupt bargain. Education and literacy. Education was becoming more accessible, but still mainly for the wealthy. The working class had limited access to formal schooling. The literacy rates were improving. How did it all feel? For most people, life was centered around work, family, and survival. The Industrial Revolution brought about massive social changes, but also created stark inequalities. Urban areas were crowded and dirty, and people often worked long hours in dangerous jobs. Life expectancy was shorter, and disease was a constant threat. But for the wealthy, life could be very different, full of new ideas, cultural events, and scientific discovery. Despite the hardships, this was a time of immense progress and change, laying the groundwork for the modern world we live in today. Life was tough for most, but hope and ambition were rising, and innovations were transforming society at a pace that would have seemed unimaginable just a few decades earlier. Right? That's pretty amazing. Pace that seemed unimaginable just a few decades earlier. Like, that's how I feel now, right? Like, we're moving at a pace now that would have seemed unimaginable in the 1970s or even like in the 2000s. It's amazing to think how far we've come since then, and exciting to imagine how much further we can go. Right? How long has life been evolving on our planet, and at what point did humans, or Homo sapiens, is that correct, show up? Life has been evolving on Earth for 3.5 to 4 billion years. Here's a timeline to give you a sense of when life started and when humans, Homo sapiens, emerged. Earth forms 4.5 billion years ago. First life, 3.5 to 4 billion years ago. The earliest life forms, like simple single-celled organisms like bacteria, appear in Earth's oceans. These are known as prokaryotes. I don't know what that means. Hold on one second. All right, I'm back. Photosynthesis and oxygenation. Photosynthetic organisms, cyanobacteria, began producing oxygen, leading to great oxygenation event 2.5 billion years ago, which dramatically changes Earth's atmosphere and allows for more complex life to develop. Multicellular life 1 billion years ago. Simple multicellular organisms start to appear, leading to the diversity of life forms we see today. Cambrian explosion 540 million years ago, period of rapid diversification of life forms. Many major groups of animals first appear in the fossil record. Dinosaurs dominate 230 to 66 million years ago. Dinosaurs ruled the Earth along with other reptiles and early mammals. They go extinct around 66 million years ago due to massive asteroid impact. Human evolution. Now on to humans and the emergence of Homo sapiens. Primates evolved 55 to 60 million years ago. Early primates, so 60 million years ago, right? So dinosaurs go away, and then humans emerge 11 million years later. Or primates do. The ancestors of all modern monkeys, apes, and humans begin. Isn't that interesting? We're like all in that category of monkeys and apes. Begin to evolve after the extinction of the dinosaurs. These were small tree-dwelling animals. So it's interesting that we don't think of ourselves as animals, right? The animals are all over there. That squirrel running on the fence, that dog pooping in the yard, those are the animals. We're the humans, but we're monkeys and apes, which is pretty amazing. We don't think of ourselves that way. Great apes, 14 million years ago. Great apes, including the ancestors of modern chimpanzees, gorillas, and humans, evolved, right? Like, we're just all in that category: chimpanzees, gorillas, and humans. Like, you could almost go see like those at the zoo. Like, they're the chimpanzees, they're the gorillas, and they're the humans. It's the zoo looking at the zoo when you go to the zoo. That's a funny line. I like that line. It's the zoo looking at the zoo when you go to the zoo. That sounds like it should be in some kid's book. Hominins, 7 million years ago, the earliest hominins, species that are more closely related to humans than to other apes, begin to diverge from our common ancestor with chimpanzees. The fossils is one of the earliest known hominins. Australia, whatever that is. The group of early hominins includes famous like Lucy. They were bipedal, meaning they walked upright, 2 legs. Genus Homo, 2.8 million years ago, the first species of genus Homo, appears in Africa. The early humans, such as Homo, had, I don't know what that is, simple stone tools and had larger brains than their predecessors. Homo erectus, species 1.9 million years ago, the species of early humans, is the first to leave Africa and spread into Asia and Europe. Neanderthals, Homo neanderthals, 400,000 to 40,000 years ago, Neanderthals lived in Europe and Asia and coexisted with humans for thousands of years. They were robust and had large brains, but eventually went extinct. And then Homo sapiens, 300,000 years ago, modern humans evolved in Africa around 300,000 years ago. We are characterized by our advanced cognitive abilities, use of complex tools, and capacity for language and abstract thought. It's amazing. So 300,000 out of like, what, 4.5 billion? So 300,000, 300. We're going to do a proportion here. 300,000. That's 300,000, right? 300,000 divided by 4,500. 1, 2, 3, 1, 2, 3 is like this percentage of the existence of the planet humans have been around, and we can make that a percentage, you know, by multiplying it by 100. 100 times that. So we've been around 0.006%, 7%, 6-7% of the time. It's like a super small number. It's like less than 1% of 1% that we've been around. So we're down there. We are characterized by this. Homo sapiens emergence of modern humans. Homo sapiens spread from Africa to the rest of the world starting around this, and during a period known as out of Africa migration. It's a book. Over time, they replaced or interbred with other hominin species like Neanderthals and Homo erectus. Modern behavior. 50,000 years ago, Homo sapiens were creating complex tools, art, clothing, and shelter. They engaged in symbolic thinking and developed early forms of culture and social structure. So symbolic thinking, that's super interesting. I think that would be like thinking in like symbolic representations, like, symbols represent stuff, letters represent stuff, words represent stuff. Like you write down words and it represents a thought, or a TREE represents a tree. Key points about human evolution. 300,000 years ago, humans first appeared, were part of genus Homo, which existed 2.8 million years. Other human species like Neanderthals lived alongside Homo sapiens, but eventually went extinct 40,000 years ago. Life on Earth has evolved over billions of years, from simple single-celled organisms to the incredibly complex biodiversity we see today. Humans, Homo sapiens, are a very recent arrival on this timeline, having evolved 300,000 years ago. So when we consider the scale of life's evolution and how quickly humans have advanced in technology, culture, and civilization, it's truly mind-blowing, truly mind-blowing. All right, and the next question I wanted to ask was about thrust propulsion. What is the possibility of no thrust propulsion? Does have humans already created no thrust propulsion? So that's like it's some sort of gravitational device, much like UFOs. I have seen some stuff in. I saw some articles in the New York Times. Saw some articles in the New York Times a few years ago, like around 2022, like around 2020 or 2022, where there was a big declassification of UFO documentation by the USA. Have humans discovered UFOs and reverse engineered them? I don't know. The idea of no thrust propulsion, often associated with UFOs and population stories about advanced technology, is a fascinating speculative topic. While there have been some high-profile declassifications and government missions related to UAPs, the modern term for UFOs, there is no publicly confirmed evidence that humans have successfully reverse engineered or developed no thrust propulsion systems akin to the capabilities described by UFOs. So thrust is like propellers or jet engines. That's thrust, and no thrust is just like it's working by gravitational pull somehow. In 2017, New York Times published an article revealing the existence of a previously secret Pentagon program called the Advanced Aerospace Threat Identification Program, ATIP. Was tasked with investigating reported UFOs. 2020, Pentagon formally released 3 Navy videos showing encounters with U.S. fighter pilots and unidentified aerial phenomena. These objects displayed characteristics such as rapid acceleration, high speeds, and the ability to change direction without visible propulsion systems. The U.S. Office of Director of National Intelligence released a report summarizing investigations into UAPs. The report did not offer conclusive explanations for the objects observed, but acknowledged that the phenomena were real and warranted further investigation, and then it all stopped being reported. What they reveal, how no thrust propulsion, has no thrust propulsion been created, reverse engineering. I'm going to read through this. You can pause the video, but I think we're going a little bit long here, but it's interesting to me. So pause the video if you want to read that, and then pause the video if you want to read that, and then pause the video if you want to read that. And I'll read it and then share any thoughts. All right, I just read through the rest of that stuff, and it's just like basically like there's no evidence that humans have created no thrust technology. We're at the end of this video, and we started out, just as a little recap, we started out like what is the difference between standard error and standard deviation, and so this is where we started. We asked this question, and then I was so impressed with this that that it had asked me a question, right? Does that help clarify the difference? Right? And I was like, yes, that's great. Thank you. I was like, wow, I'm having a conversation here. And then that led us down this entire thing where we did all this other stuff, which I think was really interesting and useful and beneficial just to kind of model using ChatGPT because it's a new tool and people need to learn how to use it. And so you're seeing somebody use it and that's helping you learn how to use it. And that's super valuable because this is what I do for a living. Like I use technology and I'm monitoring what's coming out and how all that stuff, right? And so that's what I do. And so you seeing somebody who like is at the front, like the vast majority of humans aren't doing this kind of stuff with the technology yet. So it's useful to see that. And then it's also useful just for you to see like this inquisitive spirit, creative thinking, and being curious. And learning isn't just memorizing what is already there, but learning is the spirit of exploration, the spirit of adventure, where you have questions, and they're unanswered questions. And they're unanswered questions just like you might have the unanswered question, what's on the other side of the mountain? Or what's that view going to look like when I get to the top of the mountain? Or what's at the end of this river, right? Or, you know, like, what will I discover if I go into that jungle? Will there be gold in there? Those are unanswered questions. And that spirit of adventure, that spirit of exploration draws into the unknown. And that's where learning occurs, right? And so it's the question which drives us, to quote the Matrix, right? It's the question which drives us. And so adopting that spirit of adventure and exploration and being courageous and moving into the unknown and asking questions, this is how we learn. It's not solely limited to cracking open a textbook and reading it and memorizing what other people have already discovered. You need to forge your own trail through that jungle and through, you know, through that jungle of uncertainty and move into that forest of the unknown. And that spirit of adventure and exploration to find answers to unanswered questions in you. They're either unanswered for you or for all of humanity, like that's true learning. And so you're seeing that model too. So you're seeing how to have that spirit of adventure and exploration and to be curious and to move into the unknown and to ask questions. That's like the heart of learning. And you're also seeing how to do that with this new technology, ChatGPT. So super valuable. All right, that is this video. I'm going to call this video standard error versus standard deviation, plus a whole lot on AI. See you in the next video.